What's up, everyone? Welcome to our short introduction on programming languages. So, programming what? Basically, the important thing is we need to have some way to interact or speak with the computer, so to say. And basically, what it's all about nowadays, it's really focused on the human. So, our programming languages, they're made for humans to understand and not for computers. And the idea is that everyone that programs can read it and understand it, and this makes it easier for us to write the code, and then there's some programs behind it that are going to make it readable or understandable for the computer. Okay? And what you need to think about, there's hundreds, thousands of different programming languages, and they all have different ideas, and they all are built on some philosophies. And I can tell you already, you're not gonna like them all. There's always gonna be one program language that you don't like, and in each language, at some point, if you use it enough, you're gonna be like, why did they do this? What is the reason behind this? And if you're a bit cocky like me, you're gonna go, I could do this better. And this is exactly why we have these thousands of program languages, because there always was one. Someone used it and he was like, I don't like this. I can do it better. And then he tried to do better. And some years later, someone used it, or a lot of people used it, and someone else looked at it and was like, I can do this better. And we're still at this today. Maybe not as much as before, but it's still happening. And you're gonna see some things that you don't like. So if you're into it, make your own language. Be the 1205th or something like that. But create a new language which is better than the others. Okay. So there's basically this is going to be a short guide. So there's some concepts that always are important for the program languages. And the first of all is the high level to low level. And basically the differences in the high level, which you can see here, is basically for humans to understand. So it tries to make the concepts from a computer understandable for humans. And so the code is readable, you can look at it, it makes sense. And there's low level, which is basically more for the computer. So you try to really be efficient, have the values in a computer format, and so on. So the difference is in high level, you can just write your code and the program in the background is going to make it usable for the computer. While in low level, you need to think more about how is the computer doing things and then try to make the computer do things better. And so in the beginning, usually you start at high level languages and then you go to low level. You can also do it the other way around, but I think most people recommend going high level first. And there's also maybe they're used for different things. So in high level, you might mainly write application, websites, and so on. And low level is basically when you need really fast programs or operating systems that others build on top of it. Then another thing that we have is interpreted versus compiled. And basically here the important thing is it's just how your program is going to be executed. Interpreted means you go line by line through it and then you execute it. And compiled means you first take your whole program, you make it readable for the computer, and then the computer is going to start executing it. And so this is what sort of it could look like after you compile it, for example, to a middle stage. And then your nice readable code is going to be something like this. And this is then going to be transformed into something else like ones and zeros that a computer can understand, right? And this you can't even look at it. You can look at it, but you're not going to understand it a lot. So make sure to understand what is interpreted, what is compiled. I think in Informatics 1, you're going to talk about interpretation of programs and maybe also compiling, but you're going to get into it. But make sure to also read it up yourself. Then we have dynamic typing versus static typing. So this is basically about what you can give to your variables. And so in dynamic typing, it's a bit more stretchable. So basically you can decide a bit more. If I have this variable, I can just put something in there, put something else in there and just replace it. And then there's static typing, which is basically you say, this is going to be a box and then you can only fit the square in it, or it's going to be a triangle box and then you can only fit a triangle in it. And so the big difference is on the left in the dynamic stuff, you can do stuff a lot more freely. It's less error prone, but on the right, it's more error prone and you need to adhere to the other regulations. But it's also gonna potentially make you a lot faster, like your program when it executes. And yeah, some people like one thing, some people like the other. I don't think there's a best way. Depends really on what you're programming, what you need. Then every program language has its strengths and weaknesses in the end. So low-level programming languages, for example, are made to be often really fast, really precise, while the high-level make it easy and fast to develop something. So you can write your code a lot faster, but it's going to be running a bit slower, for example. And so yeah, there's really look into it, what your project is, and see what you do. But always think about even you can do almost everything with everything. So if you never heard of Roller Coaster Tycoon, check it out. It's a really cool game. And if you look at the history behind it, it's a really cool dude that did it. And yeah, he should be your idol in the end. And this is a quote by Barnes Strustrup, I think it's called. And this is a funny quote. C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. So basically this comes to this whole idea of doing something better. So C++ basically expanded C. And as you can see here, it makes it harder to shoot yourself. So it tries to take the problem way of shooting yourself, but it also says when you do it, it blows your whole leg off. So as soon as you have a mistake, it's going to be pretty bad probably. So this is the downside of the language, so to speak. And then we have the use cases. So as we said before, you can do different things with different languages, but some are better and some are worse. And a big part is always the community. So basically, whenever you have a program language, the community that you have, it makes a lot of impact. Because especially if it's an open source language, there's a lot of different people looking at it. They see problems, they see potential, and then they're going to be like, oh yeah, we can do this better. Let's implement this and so on. And another thing is with community, if you have a lot of people using the program language, the possibility of someone having the same problem as you is quite likely, right? So if you have a lot of people using the language, the probability then you can just Google your problem and someone already solved it before you is quite high. So keep this in mind, it's a really important part. If you have a language that no one uses, you're having a hard time to find information on this. And then in the end, yeah, find the similarities, find the differences. As we said before, it's like Zootopia. Everyone can be everything. Every programming language can do everything. Not quite everything, but almost everything. So really try to find out what can you do with which program languages, find how they do it similar, find out how do they do it differently, find out with which can you do it faster, which program runs faster, and so on. And there's really, if you try to find the similarities and differences, there's a lot that you can learn about different languages and how they should be used, how you're going to use them, and so on. And really always focus on the concepts. That's what I tell everyone. So quite often, because program languages are built on each other, there are similar concepts. So think about it like this way. If a program language came out in the 1990s or 2000s, they already evolved over 20, 30 years. So the possibility of all the concepts that are in there are just bad is quite low. So the concepts that are good, they're always repeating, coming up again, and so on. And there's always new concepts coming in. So you're always going to see the similarities, and there are also some differences. And yeah, how they try to improve is basically they try to solve the problems that the other could not, and they're going to introduce some new problems, as we said before. For example, with the C and C++ example. And think about these differences, and not only about the differences, but also about the implications. So don't just say C++ makes it harder to shoot yourself, and when you do it, you blows your whole leg off. But think about, what does this mean? So, for example, this could mean if I just want to do a simple program and I want to do it quick, then maybe I should use C++ because it's harder to shoot myself, right? But if I want to do a huge program that should be working all the time and should never crash, and if it crashes, it's very bad, then maybe go for C, because with C, you're gonna shoot yourself, but you can just wait until you fix all the stuff, and then you can give it out. But with C++, if you shoot yourself and then it's just gonna blow your whole leg off, then you can't fix that easily, right? So maybe think about here, which one is better, how and why should you use it, what are the problems with it, what in the future can be a problem with it, and so on. So maybe watch a video on how to decide which language to use for what and so on. There's really, the sky's the limit. There's so much that you can talk about, think about, and yeah, really try to find these different languages and think about them, and then compare them as well. And don't just look at them theoretically, but also use them practically. So try different languages, try them out, even if it's just toying, try it out. And yeah, this will be it for today. Thank you very much for tuning in. Hope it could help you with the programming languages. And here are again the sources with the amazing free pictures. Yeah, if you ever want these pictures, just check them out. The link is here.